Today we're going to discuss about determination of calorific value using bomb calorimeter. In our previous discussion, we have discussed what are chemical fuels, classification of chemical fuels using depending upon occurrence and physical state. We have seen various examples of chemical fuels which are classified on based on occurrence as well as physical state. We also discussed what is calorific value, and we have seen different types of calorific value, what is gross calorific value and net calorific value. Today, let us discuss how to determine the calorific value of both solid and liquid fuels using bomb calorimeter. For gaseous fuel, the calorific value can be determined using Boyce calorimeter. So Boyce is the name of a scientist. Since he is the first person who designed this calorimeter, it is named after him. It's called as Boyce calorimeter. So here today we are going to discuss only about the bomb calorimeter, wherein we can determine the calorific value of only solid and liquid fuels. Bomb calorimeter is made up of platinum or ceramic crucible in which fuel sample is taken. It is kept in a stainless steel vessel which is known as bomb. This bomb, which is shown here, is equipped with an oxygen valve and electric ignition system. Oxygen valve is used to supply oxygen for combustion. As we all know, oxygen is essential for combustion. So this ignition wires is used for igniting the fuel. We cannot open the bomb calorimeter and ignite the fuel. Therefore, we have electric ignition system. So when we close the circuit, a small spark will be produced and the fuel will be ignited. So this entire setup, there is a stainless steel vessel, the ceramic crucible will be kept, is equipped with oxygen supply as oxygen valve and electric ignition system. This entire setup is called as bomb. This bomb is kept in a airtight copper vessel which is known as calorimeter. What is calorimeter? Airtight closed vessel. Okay. So calorimeter consists of known weight of water, stirrer and thermometer. Now let us see, this is the construction part. Okay, this is very simple. This is the construction part. So let us see how this calorimeter will function. So we are going to take a known weight of the fuel sample in the crucible, that is ceramic or platinum crucible. So before igniting the fuel, we are going to take the initial temperature of the water. Initial temperature of water will be noted down. The fuel will be ignited using electric ignition system. Once the fuel is ignited, fuel undergoes combustion and energy will be liberated. As we have discussed in our previous session, so when the fuel undergoes combustion, carbon dioxide, water and energy will be liberated. Carbon dioxide and water escapes into the atmosphere. Will be as it is. So the energy whichever is liberated in the form of heat will be absorbed by the bomb, which will be later transferred to the water, surrounding water. When it is transferred to the surrounding water, the temperature will increase. The rise in temperature will be noted down. So the difference between temperature, final temperature and initial temperature will be noted down. So by knowing the rise in temperature, that is difference in temperature, weight of water taken in the calorimeter and weight of fuel sample taken, calorific value of the fuel can be determined. How it is determined, we will discuss in our further slides. This is only construction part. So by looking at the diagram, you should be in a position to write both construction and working. Okay. These are the construction and working of bomb calorimeter. So whatever I have discussed in the previous slide, so same things is being put up in points over here. So this is the construction part of the bomb calorimeter. So next we'll see the working part, whichever is put up in the points. So when this is the construction part and also the working part. So once you note down the rise in temperature and mass of fuel sample is taken and width of calorimeter and other assets is noted down, the calorific value of the fuel can be calculated as follows. So we're going to note down the mass of the fuel and it will be taken as mkg. The weight of water taken in the calorimeter, we will consider it as W1 kg. And water equivalent of calorimeter. What is water equivalent? So water equivalent is weight of calorimeter, weight of water, weight of stirrer and weight of thermometer. Put all these things put together is called as water equivalent. That is called as W2 kg. So total water equivalent is W1 plus W2. So the initial temperature of the water is noted as T1 degree Celsius. Final temperature is noted as T2 degree Celsius. So difference in temperature or rise in temperature is given by T2 minus T1 degree Celsius. So the amount of heat liberated. Now how to calculate the amount of heat liberated by water? It is not only sufficient to know the temperature, there are other factors which influence. So what are those? Let us see. So the amount of heat liberated by mkg of fuel is equal to amount of heat absorbed by water and other accessories. Right, when the fuel undergoes combustion, what will happen? The heat will be absorbed by the water and other accessories. So what are the other accessories? The other accessories are calorimeter. You know that calorimeter is made up of copper. It's a very good conductor. It will absorb the heat, right? And stirrer and thermometer. We're going to consider even that also. We're going to take even that also into consideration. So the amount of heat liberated is represented by Q and by mkg of fuel. It is represented by M. So amount of heat absorbed by water is measured by difference in temperature, that is T2 minus T1, and other accessories, whatever heat is absorbed is given by W1 plus W2, that is total water equivalent. So what do we want? We want amount of heat liberated. So kick this M down. When we kick this M down, we get Q equals T2 minus T1 into W1 plus W2 divided by M calories per gram. This calories per gram is the CGS unit. We don't want this. We want whatever 10 SI units, right? So how to convert CGS into SI unit? The simple conversion factor which converts calories into SI unit, that is 4.187. So when you multiply anything which is in calories per gram CGS unit into by 4.187, it will get converted to kilojoules per kg. So GCV, that is gross calorific value, is given by T2 minus T1 into W1 plus W2 divided by M into 4.187 kilojoules per kg. So this is GCV. So next let us see how to calculate our net calorific value or NCV. So this net calorific value is given by GCV minus latent heat of condensation or steam. So what is latent heat of steam or condensation? So latent heat of steam is nothing but, so when 1 gram of water vapor is cooled to water liquid, some amount of heat is liberated. So that heat is considered in GCV, where the same heat is liberated, is removed from NCV. So how much amount of heat is liberated? 587 calories of heat will be liberated, right? So NCV equals GCV minus 0.09 into percentage of hydrogen into 587 into 4.187 kilojoules per kg. Now let us see why each and every term is included here. So 587, as we know, when 1 gram of water vapor is reduced to water liquid, what will happen? 587 calories of heat will be liberated. So we are going to include 587. So 587 calories. So in order to convert that into kilojoules per kg, you're going to multiply it by 4.187. You know that water is formed by percentage of hydrogen present, right? So if 1% is present, 1 into 587. If 2 is present, 2 into 587. If 3 is present, 3 into 587. So number of times hydrogen is present, going to multiply so amount of calories, or what water will be, energy will be liberated. Okay. The question is why 0.09? So 0.09 is, so when 2 moles of hydrogen undergoes oxidation, it liberates 18 grams of water. So for 1 gram of hydrogen, how much amount of water will be liberated? We're supposed to calculate. Just cross multiply, we get 9 grams of water. So 1 gram of hydrogen, if undergoes oxidation, liberates 9 grams. So for 100 grams, then how much? Simple cross multiplication, it has 0.09. So that is how you get 0.09. So NCV is equals to GCV minus 0.09 into percentage of hydrogen into 587 into 4.187 kilojoules per kg. This is what NCV. So thank you. Let's meet again in our next discussion. Thank you.